that's not the usual talk I would give. I will not just focus on scientific results, but also share thoughts about how to rethink how we develop science in this context. I start here with the latest update of key indicators of the state of climate and human influence, and you just see here observed temperature. And it's not the only thing that is rising. What is also rising is obstruction to climate action, expanding to attacks to climate science in unprecedented ways. For instance, in terms of obstruction, this is a graph about obstruction within the UN Framework Convention on Climate Change. It's also the case within IPCC, where there's no agreed schedule for the delivery of the main working group reports in the coming years. Another example of obstruction is the resignation from India to host COP33, an important COP because scheduled together with the second global stocktake news this week. And this brings new roles and new questions for climate scientists. I'm now head of a Climate Society Center at our cluster of climate and environment labs around Paris. And this was established considering that our science is not neutral, it's not perceived to be neutral. My generation came to climate science out of curiosity, but the young scientists who come now, they come because they want to contribute to sustainability science, not just climate science based on physics. They also want to be part of societal transformations, and that's what we want to support within this center. Of course, with pluridisciplinary approaches, but also rethinking how we develop societal partnerships, how we develop outreach. So when you think of climate science, you can also think of a first role, which was a warning. Climate is changing, it's due to human activities, as it was expressed before, and it's a problem. The second step is co-construction, how to address societal needs, how to address needs from farmers, from the private sector, so as to advance our science, but also provide responses that are actionable for society. There's also a third role, which is the watchdog role. When things derail, when things don't progress as expected, it's also, I think, our role, sticking to facts and truth, to share that knowledge. And that's part of the motivation to provide every year, based on the same data sets and methods assessed in IPCC reports, an annual update of key indicators of climate. What do we see? Global greenhouse gas emissions keep rising, slower for CO2 from deforestation or fossil fuels, but they are still rising. We can also see that the radiative forcing due to human activities is going up, both from increased effects of greenhouse gases, but also from the loss of umbrella effect, thanks to improved air quality and reduced emissions in some regions of particle pollution. And that's important to explain, because in the general public, some people also believe that climate change is out of control, that the response is being amplified, while our understanding requires to quantify the drivers and the responses. And when we look at the responses, we see, for instance, a sharp rise in the Earth's energy imbalance, which is critical to understand, to use to constrain projections. And with the stars here, we highlight the key role of some satellite products, such as Ceres, that are unique and play a key role to structure our understanding of the Earth's energy imbalance. We also monitor the accelerated rise of sea level as a direct consequence of this Earth's energy imbalance. And when we look at global warming to date, we can update what is observed warming, what is attributable to human activities, which is now reaching 1.26 degrees, and it's occurring at such a fast pace that when you go up to 2025, we are almost in a 1.4 degrees warmer world due to human activities. So the next question can be, are we able as scientists to establish when a specific global warming threshold is reached? Not that easy, because you need to define what's the pre-industrial reference, and then you need to account for uncertainties in data sets and methods, and then to account for future warming, to make sure that you have an information centered on a 20-year period. And these are efforts that we have tried to advance. In the lower panel, you see the number of days each year where in the ERA 5 reanalysis, you exceed 1.5 degrees of surface temperature. And you can see due to the El Niño events in 2023, 2024, and other modes of variability, in addition to the human-caused warming trend, we exceeded or were close to 50 or 75% of days at that level of warming. And then we can go back to 1 degree of warming. And when we look back in time, you can see that the first year where about half of the days in the year were close to that level, it coincides with the center of a 20-year period where, in average, that level of warming was reached. So that's the background, and then we, based on that, suggested a methodology and a protocol to be able collectively to report in an objective way where do we stand, including the uncertainty level, with respect to reaching different global warming levels. And you can see half a degree warming levels probably reached in the mid-1980s, in the 2010s for 1 degree warming level, and maybe by 2030, or even closer than that, for a 1.5 degrees warming level. And moving from that, of course, our knowledge shows that future warming depends on future emissions. The last IPCC assessment report had confidence in a couple of findings, including what are the key conditions to reduce emissions at a fast pace, what are the solutions that are ready, that can be implemented at scale. But of course, actions depend on societal will, political will, and finance. And of course, this is associated with large uncertainty. And I think the uncertainty is growing. It is growing in addition to the extrapolation of current policies, or the extrapolation of what would nationally determined contributions mean if implemented, or what would net zero pledges mean if implemented, which is much more conditional. New uncertainties come from structured, organized obstruction that expands to attacks on science by itself. It's also challenged by the growth in energy demand associated with some adaptation responses, such as the fast growth of air conditioning in tropical areas, but also in temperate areas. It's also more uncertain because of the growth of energy demand for data centers, stimulated by artificial intelligence and cloud computing and other dimensions. And when you see the last years marked by new conflicts, Ukraine war or Iran war, with global consequences on the cost of energy, it's also adding one layer of uncertainty. And it's quite striking when you look back at the AR6 assessment that was collectively developed, that it was very weak on aspects related to military expenses, defense, and implications in terms of vulnerability to climate change, or in terms of implications for finances and for climate action itself. So this is why I mentioned that we are facing growing uncertainties. And I would never have expected during my professional lifetime to have a duty to monitor and report obstruction to climate science taking place in the US, where, for me, support for science was an inspiration for the best of collective intelligence, investments in infrastructures, and cutting-edge research. So I try to summarize how I understand climate obstruction. So it's strategies to minimize the seriousness of environmental degradation or create silence on the topic, the rejection of clean technologies and societal transformations, in particular on the demand side, including sufficiency. It's also specific and organized destruction of environmental constraining legislation, and that's not only happening in the US. The organized blocking of multilateral fora, it's the case for maritime transportation, for plastics, and it's also the case now for climate. And it's also the framing of climate action as unfair, ignoring the unfair consequences of climate inaction. We also observe autocratic drifts and manipulation strategies that combine populism, polarization, and post-truth. And of course, science is a target in this context because it is what builds an understanding of complex, nuanced features. It is what can attest of the efficacy of public policies, and therefore it is a clear target, and not only for climate science, it's also the case for health, it's also the case for inequalities, for instance. We also see a growth in the control of media by multi-billionaires worldwide. They also control social network algorithms and resources that will train artificial intelligence tools. Just have a look, for instance, at Wikipedia and TriPoint for climate change, and think that this will drive what people will have access to through ChatGPT on a daily basis. It's well done, it's appalling. Things are cancelled. The role of fossil fuels or the attribution from fossil fuels to extreme events and impacts. It's just absent. And that's what people want to disappear from the public debate. We also see joint attacks against environmental protection, public regulation agencies, specifically, those who can translate scientific finding into regulation and related science. In Argentina, what's happening is called the scienticide, with a destruction of the Ministry of Environment, the protection of forests and glaciers, which means water, as well as climate policies. In the USA, it's very organized with Project 2025, with a so-called energy emergency, but also the wealthiest man in the world, cutting completely humanitarian support for the poorest children, which is something which should shame every of us not to react collectively. It's also the elimination of expertise structures, censorship so that scientists cannot speak out, cannot collaborate freely, budget cuts, layoffs, elimination of resource centers for water and adaptation, pressure on climate modeling centers. Just think of NCAR at the moment with huge uncertainty on the ability to preserve what I see a treasure of decades investment in cutting-edge atmospheric science. A political decision to remove scientific findings, such as the climate endangerment one, and what I describe as a secession. So just going away from any international process related to climate or biodiversity. And you can see quite clearly the loss of skills with a decrease in US federal employees that hold a PhD in health or STEM. And you can also see that even if the Congress, on a non-partisan basis, is trying to save public spending on science, in practice, the number of awards or budgets invested in science is strongly decreased in geosciences this year compared to the previous one. How to respond to climate obstruction? I think we need to contribute to the understanding and characterization of climate obstruction. And I'm very pleased that some social science colleagues in France have decided to develop a chapter focused on France to better understand the actors, the methods, the strategies developed in France for climate and environmental obstruction, as well as an objective watchdog feature. What we learn also from the US are the importance of science unions. For instance, the legal support to scientists facing layoff, the role of learning societies to maintain the nomination of US scientists for the IPCC outside a government framework, and in the absence of national climate assessment, collections of scientific advances to continue to support future assessments if recovered. There have been also collective analysis to avoid pseudoscience to be promoted at the government level. For instance, several tens of scientists identifying factual errors in the US Department of Energy, what I call fake climate report, work to preserve key data sets, and the search for non-government support for climate services and non-partisan support for scientific research. But there are many challenges. The biggest one I see now is the risk of losing one generation of students and early career scientists. So my colleagues in political sciences in France, they've just established a Paris Climate School so as to be able to offer a 2-year course for students who would have liked to do that in the US, but would do it elsewhere, so that to keep the possibility to be trained, to be involved in climate governance and rebuild things in the future. There are also key aspects regarding how to communicate, and many of my US colleagues now write more and more into the local daily newspapers, which do not belong to the same owners as the national press, in order to connect better their local communities with the importance of what they are doing to support resilience, adaptation, and the rest. We need to rethink alliances, and in particular, I think the Public Health and Climate Alliance is critical. There are many posters here going in this way, and currently in France we want to open a public debate within the revisions of the bioethics laws, so as to expand considerations of bioethics to environmental and climate determinants of health as an outcome with multiple benefits, in order also to stimulate non-partisan debates on this topic within the French Parliament. And more broadly, we are at the crossroads for support for international scientific cooperation. The budget of the World Climate Research Project has been cut by half, to a point that we need to look for philanthropics, and I'm thinking of crowdfunding as a way forward, given the minuscule amount of money that is in fact needed to keep, cooperation on key projects. Thinking of the global observing system, those involved in GCOS, they have analyzed key variable by key variable and component by component what is threatened. And it appears in particular in red for key aspects of our global monitoring system that heavily rely on one single country or one single instrument. And it's, for instance, the case for the calibration of greenhouse gas monitoring worldwide. It's the case for the Ceres satellite I mentioned before. There's no certainty on the ability to monitor groundwater on the longer term, for instance, or no coordinated funding for soil carbon, which plays a critical role in the global carbon cycle. And thinking of the ocean, you can see a number of red boxes which reflect that the monitoring of the ocean heavily depends on single countries from some aspects, and with uncertainty on the ability to continue to monitor on the longer term. And I think we need to speak out about this. We need to make the general public, journalists, really aware of what is at stake, with key aspects that have heavily advanced our understanding, model evaluation, the ability to constrain projections, and all the rest. If we lose this ability to monitor essential climate variables, it's like running blind. And many decision makers, many policy makers, many people in the general public take this as granted, and it is not. Finally, we are going into a 1.5 warmer world, and by 2050, possibly a 2 degrees warmer world. And when you look at the risk assessment from the previous IPCC report, the level of risk has been revised upwards, in particular because there's a better understanding of exposure and vulnerability. Thinking of that world, with increases in losses and damages, with increases pressures on specific climate hotspots, ecosystems that are most vulnerable and communities that depend on them, what kind of science is needed? With whom do we need to work? What type of co-production is needed? Which context to put priority on? We don't live in bubbles, and what's happening in Switzerland, heavily dependent on value chains, also depends on the ability to strengthen resilience in other places in the world. And it's obvious that it needs to be repeated to decision makers that tend to restrict their focus on narrow national interests, ignoring the multiple interdependencies. So, thinking of that, there are multiple ethical challenges. I use this figure illustrating, possible overshoots drawn as idealized lines. Do we really believe that we will be able to deploy carbon dioxide removal at scale, and limit global warming after exceeding specific levels? What are the feasibility conditions? Isn't that a hypothesis we play with? What is our role in front of a climate and environmental emergency? What are responsible research practices? Do we show the example by reducing our own carbon footprint? Do we have enough funding to strengthen participatory research projects that are key for the new approaches I just argued for? What is the ethical background we use when we think of research on and for adaptation? Considering geoengineering, we worked on specific different fora, and it's interesting that the French Academy of Sciences, with multiple disciplinary perspectives, considered that solar radiation modification should not be investigated as such, and investment should be on advancing processes associated with large uncertainty in the atmosphere, clouds, aerosols, and that's the key to provide better informed applications for solar radiation modification. But that was not the position of the CNRS Ethics Committee, which considers that there's a need for public-funded research on the topic, in particular a need, possibly, for a detection system in case a single actor would like to do real-world, large-scale injections of particles, for instance. We don't have such a detection system. And the ability to trace consequences to an actor that would do a large-scale, real-world experiment on the climate system. And the analogy is a bit like what was implemented to regulate nuclear tests in the atmosphere, and the ability to monitor and attribute consequences to an actor is in fact a multilateral regulation mechanism where the ability to monitor is part of the process to avoid such deployments. And it was also mentioned before, but I was part of a work on polar geoengineering. It was quite striking for me to see, people developing startups or ideas, looking for funding really, with ideas that need to pass a minimum of tests for what can be considered as responsible responses. And in that paper with Martin Siegert, we tried to frame how to characterize responsible responses. There are aspects regarding scientific feasibility, of course, but also environmental risks, those that can be foreseen, but those that could also be more indirect. There are aspects regarding the financial costs, and for those who have done polar research, we know the cost of logistics. Some of these ideas are completely off by a factor sometimes of 1,000 with respect to actual polar logistic costs, and we can provide verification for that. There are also governance challenges. There are also ideas that in principle could work, but then would take so much time to be deployed that they would not address the purpose, which would be to limit risks while slowly decarbonizing. And finally, there's this risk of, the economy of promises, the risk of illusions, false hopes, where as scientists willing to find solutions, we can also get trapped into that and ending promoting things that have no possibility to be real solutions. And we need to be very careful about that, even while we try to really support solutions given the scale of the issues at play. So from the scientific group that was involved in the ocean conference last year in France, we tried to frame what could be urgent shifts specific to ocean science, but in fact they apply more broadly. And why do I speak about ocean science? I also speak about ocean science because this year in our annual update of key indicators of the state of climate, thanks to Thomas Fröhlicher and Catherine and Gregory and others, we have updated the assessment of changes in the number of marine heatwave days, which now has tripled compared to the assessment in the SROC report, reporting a doubling. And that's one example where heating of the climate system directly poses a growing threat for organisms and marine ecosystems, but also fisheries and health of those who sleep near the ocean due to tropical nights. So our recommendations is to forge new strategic alliances, to rethink communication, engaging in processes, for instance, combining art and science, and make science personal and political. Recognize emotions, recognize what connects you with the implications of your work, being advocates for change. And we need institutions to support these shifts, to facilitate transdisciplinary collaborations, to reshape funding allocation focused on these alliances. We need also to invest in strategic media engagement to ensure that our knowledge can reach the society at large. We maybe need to redefine what we see as scientific impact for society. And I think we need to support science activism, sharing motivations, and the political nature in the sense of policy, you know, in the Greek term, the life of the city. And we are part of the city. We need to have a voice as scientists for our work. So altogether, it's a call to rebuild science diplomacy across scales. It's being threatened within international negotiations on environmental issues. It's discarded. Political tensions take over. It's threatened within IPCC and other dimensions. We operate in a complex geopolitical framework with many intertwined issues. We can promote pragmatic, problem-solving, evidence-based, inclusive approaches from the local scale to the broader scale. We need to rebuild long-term trust with science, protect academic freedom and independence, and that's a challenge with new sources of funding. We need to rethink science communication, for whom, with whom, and we need to protect science in these multilateral environmental assessments. And finally, in the current context, I think scientific cooperation, more than ever, is a key condition to support climate-resilient peace building. I just end with a view of the French Polar Research Strategic Plan covering the next polar year. And I think of the past polar years, during periods of war and conflict, after those periods, rebuilding cooperation. I think of my colleagues who worked on Antarctic ice cores during the Cold War with Russian, Soviet, and US scientists at the time. We can learn from them, and we can do better. Thank you.